Mr. Herder here. We're going to give you an introduction to ionic compounds, covalent compounds, and acids. Just so you know.
Bill, what? Strange things are afoot at the Circle K.
Yes, there are strange things afoot at the Circle K. So first we have to talk about an ionic compound. It is composed of ions, cations, and anions, those positive and negative ions. They are held together by electrostatic forces and metallic bonding. These compounds are neutral overall, but they consist of positively charged ions and negatively charged cations, right? In most of these compounds here, metals are the losers of electrons. Like, metals are total losers of electrons. And the non-metal is the winner of the electrons. Winners! Just so you know. Yeah. So, what happens here is that the metals lose electrons to the non-metals, which gain electrons. Okay? You have to have both for an ionic compound to happen here. Okay? The formulas you are looking for here is you are looking for a metal ion or ammonium. Remember, ammonium is one of those polyatomic ions. It's NH4+. If you see that at the beginning of your compound, it is ionic. So what happens in an ion compound here, we got sodium here, and we got chlorine here. Chlorine is the thief. And that can spell thief. It's an electron thief here, and it steals this one electron from here, and this is the electron, I don't know, loser, you know, I don't know, victim, electron, I don't know. Trying to come up with these terms as I go, you know. This is what happens, you know, just so you know. But I am still.
Don't worry, it'll all make sense. I'm a professional.
Okay. So, the next one here. We are doing covalent compounds. This is the sharing of electron pairs between atoms. Okay? This happens between two non-metals. Okay? Sometimes they are shared equally. So if they're shared evenly, this is what we call non-polar. Okay? So that would be non-polar covalent bond. Okay? But you don't have to share equally if you don't want to. Sometimes you share unevenly, which is my favorite one in the world here, the infamous polar covalent bond. Because they are polar. And look, somebody knows me very well. They got me a polar stamp. Look. Polar! Okay. That's good fun there. Okay. And when you're looking at the formulas, you're looking for two nonmetals. Okay? An acid is a compound that is capable of donating a proton or a hydrogen ion. Okay? So for the formulas for acids, you're looking for H plus and an anion with an AQ symbol. Okay, so the AQ symbol tells me that this is aqueous. All acids are dissolved in water. If this is a true acid. Okay, if it is dissolved in water, that is the AQ symbol. Okay. Now your anions can also be, you can also have H plus and a negative polyatomic ion as well with an AQ symbol. that is also an acid. Okay? So examples of acids here: HCl, which is in your stomach, by the way. It's gastric acid, also called hydrochloric acid. That would be an example of H plus and a anion, which is hydrochloric acid. Or you can have ones with polyatomic ions like H3PO4, which is my personal favorite. Phosphoric acid. Should I go get some phosphoric acid? Sure, go get some phosphoric acid, Mr. Harridan. You need your phosphoric acid for the day, Mr. Harridan. Mr. Harridan enjoys his phosphoric acid because that's in his soda. He drinks a lot of phosphoric acid in his life. You know what's also in soda? Carbonic acid too. I drink a lot of that too. That's in soda as well. But the big thing here is you're looking for acids. They have to start off with H plus here. And then these you have to balance charges in formulas. Like ionics. Okay? Because you have to gain and lose the same amount of electrons here. Okay? So when you go up to ionics, I need to put this point in here too. You have to balance charges in formulas. You do not have to balance charges in formulas for covalent compounds. Okay? That was a great video. You know.
Excellent!
Okay. You guys are champions. The legend is out. If I can get to the stop button in my